In this section, we're going to learn about series and sequences. So sequences are a listing of numbers, and a series is an addition of numbers. And so we're going to start with the arithmetic sequence. And the arithmetic sequence is a listing of numbers where you add the same number to each term to get to the next term. Such as if you had a sub 1, which is the first term, it's equal to the first term, of course. A sub 2 is equal to the first term plus something called the common difference, which is what you're adding to get to the next term. If you looked at the third term, a sub 3 is equal to the first term plus 2 of the differences. The fourth term is equal to the first term plus 3 of the differences, and that's how you develop the formula. The nth term is equal to the first term plus n minus 1 of the differences. See, 3 is 1 less than 4, n minus 1 differences. We're just going to use this formula over and over again. So, for example, if the question is find the 100th term of the arithmetic sequence, then the question is, all right, the 100th term is a sub 100 is equal to the first term, 1.6, plus n, which is 100, minus 1 times the common difference. Now, the common difference, you're either thinking positive or negative, and it's going to be 0.7. So it's going to be 0.7 here, which means that it's 1.6 plus 99 times 0.7, and that will give you your answer. Similar type of question number 2. Number 3, find the first term of the arithmetic sequence, for which the 15th term is 30, and the common difference is 1.4. Again, using the same formula, I'm going to say, okay, the 15th term is equal to the first term plus n minus 1 times d, and just substitute numbers in and solve for my first term. 30 equals the first term, which is going to be what I'm trying to solve for, plus 30 minus 1 times the difference, 1.4. That means it's going to be 30 equals the first term plus the 29th times 1.4, and you can take it from there to solve for a sub 1. Going to the next slide, the question next is, what is the common difference if you know that this is true? The common difference, so I'm going to say the 40th term is equal to the first term plus n minus 1 times the common difference, d. So again, substituting in and solving, that's times d, and then you would just go ahead and solve for d. Subtract 6 from both sides, and then you would divide by 39. Write the arithmetic sequence that has 3 arithmetic means between these two. So that means that you have 17, 1, 2, 3 means between. Arithmetic means that you add them up and divide by 2 if there are 2 of them, but here you have 3 of them. In other words, what you really want to do is determine what is that difference and then just add it on. Now, I'll do it a longer way and then go back and do it a shorter way. 39 equals the first term plus how many total terms? There are 5 total terms. 5 minus 1 times the common difference, d. That's going to be 22 equals 4d, or d is equal to 11 halves, 5.5. So this is 22.5, 28, and 33.5. 5.5 would get you to 39, so you did that right. Now, the other thing that you could do is, this is an OR situation. You could take 17 plus 39 and divide by 2, and that's going to equal 28, which is that middle term right there, and you could do that again. That's if you have an odd number of arithmetic means. Now, the second type of problem that we have in this section is, how do you get a quadratic from this formula again? Now, this is the general form of a quadratic. And if it's giving you a listing of numbers and saying that it's quadratic, then you can determine what that quadratic is. All you need are the first 3 numbers. Now, this means that where n is 0, you get an 8. we're saying the zero term, in this case, would be the first term. This is going to be where it's 1, it yields 3. Where n is 2, it yields -6. And what I'm going to do is substitute these values right here for my a sub n and these numbers for my n. And when I do so, I get this. For example, if I looked at 1 is my n, and I'm plugging it in for this n, and it's going to yield 3. So I'm going to take these three equations, and if I can solve for my a, b, and my c, then I can get this general equation by substituting back in. So the first one is just 8 is equal to c. 0 times anything is 0. The next equation is 3 equals a plus b plus c. And the last one is -6 equals 4a minus 2b plus c. Now, you could do this by matrices, but it's easy enough because you know that c is equal to 8 here. So you could write this in two different form. A plus b, if I put an 8 in here and subtracted it, you get -5. And again, 4a minus 2b equals, if I put an 8 in here and subtracted it, -14. And then if I multiplied the top one by 2, the top equation by 2, you're going to see that these actually cancel out. So it's 6a equals -24, which means a equals -4. Now you have your c, you have your a, you can go back in and get your b right here. So 3 is equal to -4 plus b plus 8, and let's see, this is 4, -1 equals b. Therefore, all in all, we know that the formula now, the quadratic model, is equal to a sub n is equal to a, which is -4n squared, minus b, or plus -1n, and then the last one is plus c, which is equal to 8. And that means that when you plug 1 in, or 0 in, you're going to get 8. When you plug 1 in, you're going to get 3. When you plug 2 in, you're going to get -6. If you graph this, you could graph these points. And so that's a little bit on getting a quadratic equation, giving a listing of numbers if you know it's a quadratic, as well as using the arithmetic sequence formula.